Hello, this is Mark Roberts from Red Hat, and welcome to this technical talk on Red Hat Advanced Cluster Management for Kubernetes. Now, in this presentation, I'll be taking you through some slides, and I'll be showing you Advanced Cluster Management running in a demonstration as we go through. Now, Kubernetes adoption has grown dramatically, and many people find now that they are running and needing to manage multiple clusters. And the infrastructure and operations teams are finding that they have to create new clusters, they have to take old clusters down, and the management of them can become a little bit of a headache. And then we think about the applications that are going to run on these clusters, and that's something that needs to be managed as well. Now, many people will have multiple clusters for a variety of different reasons. We might need to isolate development work from quality assurance and quality engineering, keep that separate from production. And in production, we might need to have multiple clusters spread around single locations or multiple locations for reasons of application availability, maybe for the data residency rules that an organization may operate under. It might also be for disaster recovery, so that you have an opportunity to take clusters down for maintenance if ever that is necessary, or for eventualities where you may lose access to a particular environment. And we're also finding now becoming more and more attractive for organizations to run edge clusters, where they have smaller clusters out in regions around the world, maybe in particular parts of an organization. But many of these clusters, as you can see on the left-hand side, need to have access to a container registry where the images are held that will be used within those clusters. So a development environment where you consume and create new container images that are stored within the registry, and then QE and production environments will consume those different container images. Now, depending on your role within the organization, you will have different requirements. If you are in IT operations, you might be concerned with how you manage the life cycle of your clusters, regardless of where they are located. And you might want to have a single view of that so that you can see your entire estate in front of you at any point in time. And that would then allow you to find the root cause of failed components, how you allow you to manage and monitor things across multiple clouds, where you may be using AWS, Azure, IBM, and Google Cloud, on-premise, bare metal, virtualized environments. You could have clusters spread across all of these different types of environments, and managing those can be complicated. From a site reliability engineering and DevOps point of view, you want to get a simplified understanding and view of your cluster health and the impact that that cluster health will have on your application availability and on your organization's capabilities to deliver new applications and maintain the service that you provide to your customers. So you're looking at automation. You want to provision and deprovision clusters as required to support the business, but while still doing that in an economical manner and making good use of cloud resource. You might want to consider how you place your workloads around the world based on capacity and policies, given such things as data sovereignty rules and where data can actually be placed. And you want to push application updates through to production as quickly as possible. So identifying that route through your quality engineering, through pre-production and into production clusters. And our final persona to think about is our security point of view. Within the organization now, we're creating multiple clusters. We want to manage those and make sure that they all remain compliant, such that they are operating within your defined policies. How do I set consistent security policies across these environments? How do I make sure that development is the same development regardless of which cloud it's on? How do I make sure that my production clusters are operating and are being maintained within the policies that we've put in place, and there's no configuration drift? And where there is configuration drift, how do I call that out, and how do I remediate it quickly? So those are some of the challenges really that organizations face when they are starting to put in place multiple clusters spread around the world across different cloud environments. And how do we manage that? So let's introduce Red Hat Advanced Cluster Management for Kubernetes. Now, within a Kubernetes environment, there are many, many different resources and operations going on. In the gray box at the bottom there, we have the basic core capabilities of the OpenShift container engine, giving you a basic Kubernetes environment. most of our customers adopt for OpenShift Container Platform. And this gives you the additional services of the service mesh, the pipelines, the CI/CD capabilities, operational characteristics like cost management. You get the ability to run multiple different applications on there for a variety of languages, database platforms, integration technologies, and various runtimes. And then we have all of the developer services, such as plugins into your favorite editors, developer command line interfaces, and a complete development environment running within a container if you wish. So that's the kind of development and operational and runtime environment of OpenShift. And as an organization managing multiple clusters, you may have these across physical, bare metal environments. You might have virtualized environments, private cloud, public cloud, or even a managed environment that is offered against various different cloud vendors. You may be running all of these different types of platform types really across multiple environments, and you need to manage that. And that's sitting on top is where advanced cluster management comes in to give us the ability to control the creation, the discovery, the compliance, and the workloads that we place upon them. And that's what we're going to explore now, looking at these four major areas of cluster management. So we have the cluster lifecycle. How do we create and manage our clusters operating within this environment? Then thinking about the application lifecycle. How do we create and deploy our applications within this type of environment? And how do we govern that and make sure that our clusters remain governed and of low risk and are compliant with the policies that we want to operate? Now, the last one's quite interesting, the end-to-end visibility, in terms of how do we find things? How do we look at cluster health and understand the health of the various clusters that we have? And how do we find different resources across multiple clusters? You might be aware that a particular route is not responding to requests from customers, but you've got 5 production servers. Where do you find that route? How do you know where it's located? Well, we have a search capability across all of your clusters, so you can very quickly find the resources that you need and help you track things down very quickly. So let's start off by thinking about the cluster lifecycle and how we create clusters. Now, you can create new clusters in a variety of different cloud locations. You can also create them on bare metal now as well. And you may later delete a cluster if you have created it through advanced cluster management. You can also import an existing cluster. So this allows you to add clusters from a variety of different locations into the environment. Maybe you have pre-existing clusters that predate the implementation of advanced cluster management. You can bring all of those into the fold as well if you wish and manage all of those clusters. So you can add those into the managed set. Now, you may later remove those clusters from ACM management, but you can't delete them from ACM. So advanced cluster management can only delete what it creates from a cluster perspective, but you can import things in and you can later remove them if you wish as well. And you can manage the clusters through their own life cycle. So this will give you a single management interface in which you can see the clusters that exist. You can see the versions of those clusters and you can perform upgrades on them as you go through that management life cycle in advanced cluster management. So this graphic here now is going to run through a couple of times as I'm talking through this. This is showing you how you can create a cluster using advanced cluster management. So you give it a name, you identify where you want it to run, and you can then look at the YAML that will be used to create that cluster. So in the left-hand side, it's going to refresh through again in a second. You'll be able to see it from the beginning. But basically, we give the cluster a name, we give it a base DNS domain. We then select the distribution, which is Red Hat OpenShift. We then select a location of where we want that to deploy, either a cloud or a bare metal. Then we provide credentials that will be used for the connection to that particular cloud environment. And ultimately, then we hit create in the top right corner there that you can see. And it's as simple as that. You provide your AWS credentials that would go in as a secret and then hit create. And the job is done. Very, very simple. Once that's been done, you can then see the cluster that you have created. And you can see that we have some labels applied to it there that identify the cloud that it's running on. We have the console URL there, so we can quickly jump across to that particular cluster. And we have the status. And there's not a lot going on in this particular cluster just yet. shows the nodes that we have, but there's no policy violations and there's no applications deployed. So before we move on to the application lifecycle, let's go and actually import a cluster into Advanced Cluster Management. Now, in true Blue Peter fashion, I have clusters already available to me. So let me walk you through a couple of these tabs that we have here. So in here, I have my hub cluster, my management cluster that's running the Advanced Cluster Management content, the operators. And this is the hub from which I will manage all of my applications and clusters. And I can tell that by clicking on these 9 blocks up here for the applications. And one of the options I have is Red Hat Advanced Cluster Management for Kubernetes. Now, I've gone through to that already and logged in. So this gives me my Advanced Cluster Management for Kubernetes URL, my web user interface via the URL. And I can see those 4 main aspects. So I've got my cluster lifecycle, application lifecycle, visibility, and governance. And those are the 4 major aspects we're looking through today. I also have my managed cluster, and I have a simple application running on here already that I'm going to use shortly for part of the demonstration. But to begin with, we want to go to cluster management. And within here, what you'll see is that we only have one cluster available at the moment, which is the cluster that we are looking at itself. So I'm going to go and add a cluster. Now, instead of creating a cluster, I would like to do that. We'll have to sit here for around 20 or 30 minutes while it does that. So I'm going to import my existing cluster that I already have. Now I'm going to give this one a name. Let's just call this Dublin. Let's assume that it's in the Dublin location. I'm going to let it auto detect where it is. And I'm going to give this environment of dev. Now that's quite important because later on, I'm going to be applying governance rules to this cluster. Those governance rules will apply to my dev clusters. I might have different governance rules I need to apply to my production and pre-production clusters. But for this, I'm just going to be applying this to dev. Now, that's all the information I am going to provide. And I'm going to generate a command now. And it's going to take a second or two, but once I've got that command, I'm going to go and copy it just by clicking on here. Let's copy that command. And I'm now going to go and paste that into the cluster that I wish to import. Now, I already have a terminal running on that cluster. So I'm going to go and paste this command in here. And it's a rather large command, as you can see. Finishing off with, it's a base 64 encoded, so it's going to do a base 64 decode and apply that into a kubectl apply command. And let's hit that. And it tells me that some custom resources have been created. So a number of custom resources are now being pulled down into the cluster that's to be managed, and that will start that process off. So if we now bring this back up and have a look at my list of clusters, we already see that we have Dublin in the list and it is pending an import. Fantastic. So we're on our way. That will take 2 or 3 minutes to go through. So while it does, let's go and have a look at the application lifecycle back in the slides. So we want to manage applications across these multiple clusters that we are managing. And to do that, we create a number of new custom resources. So you can see here that we have custom resources for the application, subscription, channel, and placement. Let me explain those. So the application is just the definition of an application that we wish to deploy using Advanced Cluster Management. The subscription is really a bit of a director because the subscription points to the channel. And the channel is where we identify the location of the resources for the deployment. And the subscription also points to a placement rule. So effectively, the subscription is looking to the channel to say, where is the content that I wish to deploy? Where is the definition of this application? The placement rule says, and where do you want to put it? Now, I can show you those in a second when we start to have a look at those in a little bit more detail. But this diagram that we've got here effectively gets replicated within the web user interface of the Advanced Cluster Management in the topology view. So here we can visualize the resources that we have for an application. So you can see there at the top in the purple circle, we have the application that comes down to the subscription, and then to the side we have the rule. So similar to what I sketched out a second ago. And that follows down then to the cluster. Then we have the deployment, the replica set, and the service. So I can stay within my hub cluster and I can look at the applications that exist and I can click on the various nodes within the diagrams and look at information about them. So at the moment in this diagram, we are clicked onto the replica set at the bottom. As you can see, the detail has popped out on the right-hand side for that. And we see a little bit more detail stepping down the screen there, telling me about the pods and the host that it's running on, and so on and so on, and the status. So we're getting some useful information there in terms of what that looks like. So let's have a look now at some of those assets and see what they actually look like. Let's just go back a slide and we'll step through the application, subscription, channel, and placement rule. And to do that, I'm going to flip across to my editor. So in my editor here, I have the definition of the application. Now the application is quite straightforward. It's a new type of Kubernetes resource, and it references the subscription, and we are looking for a matched expression of app equals layers app. So let's go and have a look at the subscription. And the subscription is here. It has a name. It has a label that matches the matching rule that was in the application. And it has a reference to the channel. And the channel has the namespace on the front of it, layers, and layers app latest is the name of the channel. So let's have a look at the channel. And here is the channel with that name in the same namespace. And here is the definition of the GitHub repository where the content is resided. So let's go and have a look at that GitHub repository for a second. So this is that GitHub repository. As you can see, we have a variety of different folders within here. But the one I glossed over a little bit going back to the subscription over here on the left is that we have this special rule here, this annotation for GitHub path with the value of application. So that means once you've gone into the GitHub repository and cloned it into the process, we want to go into this application directory. And in here, we see a customization file. And the customization file is referencing my application deployment, my service, and my route. So I get everything deployed, directed by that customization file. And that's pretty much all of the rules that I need to see. The last one that we haven't seen yet is the placement rule. And the placement rule has this important section down here, matching labels of environment dev. Now you saw when I was importing my Dublin cluster that I gave it an environment of dev. So if I hadn't have done, if I'd given it production, then this placement rule wouldn't apply to that, and that wouldn't have worked. So let's go and have a look now at what we have in terms of our cluster. So let's go back to advanced cluster management. And there we are. Our Dublin cluster is now running and is ready to operate. So I can go into my Dublin cluster and have a look at it. I see my console URL. It's got 5 nodes in there. We have no applications or policy violations in place at the moment. And I can look at further detail at the nodes. So I can see the masters and the worker nodes and so on, and see information about them and exactly where they are running, the region and the zone, and so on and so on. So some useful information about that. So now we want to go back to have a look at managing our applications. And as you can see, we've got no applications listed here at all at the moment. So we want to go and create our application from some YAML code. Now, there's a few ways that I can do this. I can use the OC apply command on the hub cluster. That's one way I can do this. Another way is that I can use directly in here. I can just hit this plus sign and I can paste the YAML into there. I can automate it with Ansible. There's a variety of different ways that I can go and create that content. So I think for now, what I'm going to do is I'm going to go back into managed applications. Shows that I have none in the list there. So let's go and start creating that content. So let's move that over a little bit and have a look what we have in here. So here is all the different content that I want to create. So first up, I'm going to go and create the namespace. So that's been created. Then I'm going to go and create the application. That's been created. Oops. let's create the channel. Let's create this subscription. Oops. There we go, create the placement rule. And you can see on the left-hand side now, things have started to appear. So I now have my layers app over here, and it's starting to create content within it. So let's give that a second or two, and that will refresh, and we'll get our application created. There we go. Let's make this a little bit bigger. Scroll that down. So there you go. We have everything that's just been created for us. And if we click on one of the resources within here, look at the service, for example, we can see that it is of type service. It's within the namespace layers that we created. It has a label and it has a location on the Dublin cluster. So that is ready to go. That's launched. And you can look at the YAML for it. And there we go, get a lot more detail about that if we wanted to see that. Just close that window. So we have everything created. There's our application. It's running on the Dublin cluster now. And if we have a look at the root, there it is running on the Dublin cluster. So let's click on that, and there's our application running. It's not the most exciting of applications at all. It just shows us the URL, and every time we refresh, we get a count that is incremented there on the right-hand side up to 23. So that application is running, but we've done all of that from the hub cluster. We've deployed that out to our Dublin cluster. We've got the URL there for the application, and it's running. We can keep an eye on that. We can redeploy it. We can do lots of things. Now, I could have deployed that out with my placement rule to a dozen different clusters at the same time if I'd wanted to, and see all of those on this same type of diagram and step through where they are. You can see quite nicely on here the really important bit in the center there where it shows cluster is it names it Dublin underneath our subscription. And we can see that we have all of the different resources running underneath that. So fantastic. We've deployed our application out into our Dublin cluster from the hub. Great. So let's move on a little bit now to looking at governance, risk, and compliance. Let's have a look at this area, which is really important. Now, there are three main different types of policy that we can put in place. There's configuration, certificate, and identity and access management. And if we have a look at configuration first, this allows us to manage certain Kubernetes resources and make sure that those Kubernetes resources exist within the clusters that we wish to manage. So this can be things like resource limits on development clusters, perhaps policies for egress and ingress on different production clusters to make sure they are really connecting to certain types of environments and so on. And as you can see from the table on the right-hand side, we can inform about configuration issues, but we can also enforce them. So if those policies, such as a resource limit, don't exist, then we can actually reapply them to the cluster and enforce them and make sure that they do. When it comes to certificates, it's a bit harder to enforce that really, because you have to come up with the process that would be applied for how to put in a new certificate. Where are you going to get it from, and how do you need to apply it? So we inform on that one, and we can detect certificates that are close to expiration. We can set the minimum duration parameter for certificate validity, and we can call out any that don't apply. And similarly for identity and access management, things that we can do with that are we currently just check the number of cluster administrators that we have within the clusters. So enforce or inform, everything has inform. The only thing that has enforce right now is around the configuration. And the things that we can put in place around the policies, or we can define what we want to check and potentially enforce. So we have different policy templates for things like image vulnerability, for memory uses, namespaces, pod security roles, and so on. So you can define how you want a cluster to behave in terms of roles and securities, and then you can allow advanced cluster management to push those out into your clusters as you create them. So this can dramatically reduce the amount of effort it takes to create new clusters, because obviously creating a cluster is pretty straightforward these days, but applying all of your different policies on top of it to make sure it's ready for use is another kettle of fish and is further work to be done. Now, we also have a thing called a placement rule within the governance area. This identifies the clusters that are to receive that policy, and we have a placement binding which will connect the policy with the placement rules. And I'm going to show you some of those in a second when we come to apply them. And we have built-in CIS compliance policies and audit checking. So here is an example of a policy. This one is a limit memory policy. So we can see some summary information about it at the top of when it was created, the namespace that the policy exists in. So here we are creating our policies in their own namespace. And we have the placement rule there at the sort of bottom left of the screen with a matching expression it's looking for. So this is looking for environments that have the value of dev. And it's going to apply this limit memory policy to that particular cluster. And if we have a look at the sort of diagrammatic relationship of these, they will exist within a namespace, and they will have the placement rule that identifies which clusters it will apply to. We have the policy that identifies the rule or the regulation that we are applying or looking for, and then the placement binding that ties the two together. And this is what it looks like if you have a number of different policies in place. So you have a number of policies listed down there, various links through from them to different standards and controls and categories that they apply to. And you can see where you have cluster violations at the top as well. Lots and lots of further information behind the scenes in terms of these, of how these governance and policies will apply. So here's another policy example for a certificate. So this one is looking for a certificate that expires in less than, in this case, 2,200 hours, which is about 90 days. And if we find an example of that, then it will be called out. And as it shows there in the right-hand side, in the screenshot there, we have a decision identified that we have a non-compliant cluster. And we can find out exactly where that is. So, and if we look at, before we move on to that, let's have a look at an example of using governance, risk and compliance. So I have some files created that will show this. So let me close these down here for the application side of things. Let's now move into policies. So we have a placement, we have a policy rule. So let's have a look at the placement rule that says we are looking again for environments that have the word dev in. We're also looking for a condition of managed cluster condition available is true. So this is identifying that it is currently a managed cluster. We have a placement binding that will tie together my placement rule that we just looked at with the actual policy called policy limit memory. So let's go and have a look at that policy now. And here is the policy called limit memory. And what we see within here is that we basically have an object definition for a configuration policy. And that is going to limit the memory usage to the values that are specified down here at the bottom of the file to various different namespaces, excluding the ones named here. So the highlighted section here are, we're not going to apply this to the namespaces that begin kube, OpenShift, OpenCluster, default, and so on and so on, because we don't want to limit the clusters that the namespaces that effectively manage the cluster. So you can decide where you want that to apply. So I'm now going to CD to a different directory. Let's go into the policies area, and I'm now going to go and create the namespace. So I'll do an OC create namespace. So that's creating the namespace to hold the policies. And this is all being done on the hub cluster, don't forget. I only do this once on the hub, and it will identify from the placement rule the clusters that it needs to push out this rule to. Before I do that, I actually probably need to show you that there's nothing in place already. So if I go across to my topology for my application, I have a very simple application running on here. And if I go to my administrator view, then what you'll see down here is if I go to limit ranges for my project, there are no limit ranges applied. So let's see what happens to that when I go and apply something. So let's go back to the editor so I can see what I need to do. And I'm going to apply these files here. So let's apply to an OC create on the config placement rule. Let's do the config limit range. And let's do the placement binding. So that's all of them created. I think we've done the placement rule, the limit itself, and the binding. So those should all be in place now. Let's go back to here and let's have a look. And there it is. It's just appeared. So the limit range has just appeared, called default limit range. We have a look at that and you can see the limits there. We didn't look in detail, but those are the limits that have been defined within the YAML that we looked at earlier on. So that's just applied that. And if we go back to Advanced Cluster Management, and if we now go to Governance and Risk, and we see that we have our policy in place, our policy called limit memory. Now we also have another policy that I want to apply around certificate management. If we go to terminal on the cluster, then I have this command. It's just run at the top there. I ran it previously to make sure it was working okay. And this basically is doing an OC get secret on the ingress certificate, and it will show that it is not valid after April the 4th this year. So the cluster was created today, January the 4th, and the certificate will expire on April the 4th this year. So we're now going to go and apply a new policy, and we have one more policy listed in here, and that is for certificate expiration. So let's go and apply that one. So it's used the certificate placement binding. Actually, it's all within that one file. If I go back and show you that file, let's go back and have a look at certificate, this one here. So we've got the policy and the placement binding within the same file. It's using the same placement rule that we had earlier on. So it's going to look for dev clusters. And we specified that our certificate should have a minimum duration of 5,000 hours available to them. So let's just go back in here now and go back to the governance and risk area of advanced cluster management, and we see that we have our policy certificate has been applied and we've got a cluster violation on there. So let's open that up and have a look at the detail, and it tells us that our Dublin cluster has a policy violation for that particular standard. So we can have a look into that in further detail, find out exactly what's wrong and what remediation action we need to take for it. That's fantastic. So we've now looked at how we can enforce some specific rules on our developers within the clusters to maintain the health of our clusters and make good use of the precious compute resources that we have. And we've also had a look at how we can identify certificate errors on the cluster itself and call out action that we need to take to make sure that we don't have certificates that are out of date. So let's finish off by having a look at a few of the additional features on Advanced Cluster Management and have a look at the environment visibility view. So here we've got the environment overview. This shows us the clusters that we have. Not a particularly exciting one here, unfortunately. We only have one cluster that we're managing. It's on the Amazon Web Services cloud, and we can see that it's actually not compliant. This screenshot was taken after the certificate issue was raised that you just saw previously. But we can see the overall pod health. We can see the overall cluster health is pretty good. We just have something to drill into and have a look at in a bit more detail. Looking at something slightly more interesting, this is a screenshot taken from an environment that had multiple clusters under management. So you can see there that some of them are offline. We can see the versions of Kubernetes that they have on them. We can see information about storage and memory and CPU and all the labels that have been applied. So there's the labels there in that sort of central section that are really important, because those are the labels that we'll use within our policy controls to manage which particular applications get deployed to which environments and to manage which governance rules are applied to some of those clusters as well. Now we have a managed search capability, which is really useful. This allows to search for any Kubernetes object across all of our clusters. Now you can guide the filtering by saying you're interested in a particular namespace, for example. So here I'm looking for a namespace called layers, and I'm looking for an object of type deployment. That's all I know. Where is it? Well, at the bottom there in bold, in black, it shows that we've found an object of type deployment. It's called layers, layer 1-v1. It's in the namespace layers, and it's on that particular cluster called my OpenShift cluster, which is really useful to have and a great search facility. If you've got multiple clusters to manage, then I think you pretty quickly start making use of this to find things. There's also a visual web terminal built into Advanced Cluster Management. This allows you to run Unix commands such as OC, kubectl, and Helm across the environment. It gives you some nice pop-up help on the right-hand side. So if you're slightly new to some of these commands, or you're using some of these that you're not that familiar with, this is a great facility. You can also use things like command line search as well. So for example, here we have a command that will search for kind deployment, owner mroberts, and look for any of those types of resources. The help pops up on the right hand side, as you can see on there, which is quite nice to see, nice to use. And when we use this and look at the results that it will give us, it gives us our Kubernetes resources broken down into these nice blocks here. So this is showing an example of using the OC get all command within the Visual Web Terminal. So it's showing me various different Kubernetes resources listed there. And as we drill into each one, we get further information. So looking at that service, we see the cluster IP address and the summary information on the left. But when we click into it, we get further information on the right-hand side, even showing us things like events and the overall YAML for it. And I have to keep reminding everyone that this is really important to show that you are looking at this from the hub, and you are looking at a view across all of the clusters that you will manage. So some of the benefits of OpenShift and Red Hat Advanced Cluster Management for Kubernetes is that it will accelerate how you move from development to production. The self-provisioning of new clusters allows teams to create the clusters that they need, removing the bottlenecks within the organization that can often involve. We get the increased application availability by using our placement rules. We can quickly deploy applications out to clusters and distribute them based on labels. So if a new cluster spins up, it's just yet another production cluster. It has the production label. All our applications that are already deployed to production will start to flood out into that new cluster that's being created, which is a fantastic way to distribute applications. And we can reduce costs because you are centralizing the management of all your cluster activities. You don't need to have dedicated staff in each of the locations where you need to run a Kubernetes environment. You can manage it centrally from the advanced cluster management capability. And finally, you can manage your compliance. And this will allow you to manage the policies that you define for how you want to operate your clusters, allow your security teams to have confidence that the rules that are being put in place are actually being applied and are being enforced on all of the clusters that you manage. So I hope this has been a useful session. Thank you for your time. If you have any questions, please contact me, Mark Roberts, at mroberts@redhat.com. I'd be happy to talk to you about how you want to use Red Hat Advanced Cluster Management for Kubernetes within your environments. Thank you.